Hello guys, welcome back to EdSTEM tutorial video on Arduino project. And today we are going to look at how to use infrared remote and receivers on Arduino. Okay, how to use infrared remote and receivers on Arduino. And in case you haven't done so, kindly subscribe to our channel, like the videos, drop the comment, and share the videos as well. And do not forget to turn on your notification bell so you get to be notified whenever a new video like this is dropped. In EdSTEM, we are a community of creators, critical thinkers, and problem solvers as well. All right, so for today's project, we are going to be making use of course, our Arduino, our breadboard, and here we have our infrared receiver. Okay, and also we're going to make use of infrared remotes. Okay, infrared remote. You can use any of the remote, but for today we are using this particular remote. This particular remote is not the one that comes with the kit. Okay, I have a remote that comes with a kit, but unfortunately it appears that I have to insert the battery into the remote, which I don't have at the moment. But however, we can still make use of this remote for this project as well. Okay, so like you all know, before we continue with our setup, I like to explain the concept, the theoretical concept of what we are doing. I believe it helps to better understand, or should I say, to better appreciate, the project, the more. All right. So I would like to quickly run through the concept of infrared remote and receiver so that we understand the theoretical aspect of it. Okay. So now basically, the remote control has LED. Okay, this is the remote control, right? And this remote control has LED that generate lights in what they call the infrared spectrum. Okay, now we have what they call the electromagnetic spectrum. Now this electromagnetic spectrum contains different forms of electromagnetic waves, right? So now infrared happens to be a part of this spectrum. Right, and this LED generate light in that spectrum. I'm going to show you the spectrum in a jiffy. Right, so now the receiver, this is the receiver. This receiver happens to is a photodiode that detects infrared light. Okay, it's a photodiode that detects infrared light. Now I'm going to show you what I mean by the electromagnetic spectrum and where the infrared light falls on. Okay, so here is already drawn diagram, or should I say a sketch of what electromagnetic spectrum looks like. Now it comprises of the radio wave. Okay, from there, if I'm moving from left to the right, the radio wave, the microwave, the infrared, the visible light, the UV light, the X-ray, and the gamma ray. So now the infrared happens to fall in between, before the visible light. Okay, it happens to fall before the visible light. So the infrared remote, the LED of the infrared remote transmit light in this infrared spectrum. Okay, and the LED, the infrared receiver, is able to receive light from this infrared spectrum as well. Okay, so that is what the electromagnetic spectrums look like, and where the infrared light falls on. Okay, so from the electromagnetic spectrum, if you observe, you can see that the wavelength decreases from left to right. Subsequently, I'll be making tutorial videos on chemistry and physics and other subjects as well. So probably in one of my physics class, I will explain the concept of this electromagnetic spectrum. Okay, so I just use this to show you where the infrared light falls on the electromagnetic spectrum. Okay, so now the LED on the remote generate light in the range of this infrared. Okay, but the thing is this, all right, now the infrared light is also found in nature. The infrared light is also found in nature. Just like you can see that the infrared light is close to visible light. This visible light is the light that is visible to us, like the light from the daylight that is visible to us, right? So this infrared is close to this visible light. So there's a possibility that the visible light as well will contain some atom or some small amount of infrared light. And also most of the bulbs, like the tungsten bulbs, they also will produce infrared light. So there are a lot of sources around us that naturally produce infrared light. Okay, so there has to be a way to ensure that this receiver only picks up light from the remote. Okay, there has to be a way to ensure that the receiver only picks up infrared light from the remote. Okay, if not, it means that there will be interference from the surrounding infrared light. Okay, so now this will happen. The infrared signal on the remote, okay, the infrared signal on the remote is actually encoded, okay, on a particular carrier frequency. All right, let me turn this part. Okay, so now the remote is encoded, okay, on a particular frequency, and that frequency is usually 38 kilohertz. Sorry, 38 kilohertz. Okay, so now the receiver has this receiver has a band filter that blocks all other frequencies. So by doing so, other form of infrared light from the surrounding would not be able to be detected by the receiver. All right, so that's what happened. And when you press a particular button on the remote, let's say press this. Here is you have this this remote is for RGB LED light. Okay, so let's say you press this particular remote button red. Okay, now the remote, when you press the remote, a binary signal of the button is sent to an encoder of the remote. Okay, so when you press this particular button, it sent a binary signal to the encoder of the remote. Okay, now this encoder then converts it into what they called a modulated voltage signal. So you have an encoder here. Okay, the encoder inside the remote. Okay, the binary signal from the button is sent to the encoder, right? And this encoder then converts the binary signal into what we called a modulated voltage signal. A modulated voltage signal. Can you see what I'm writing? Modulated voltage signal. Okay, in short you can call it MVS. All right, Now this MVS is then sent to the infrared LED, this infrared LED. Okay, the MVS, the modulated video signal that is produced by the encoder, all right, is then sent to this infrared LED. All right, then the infrared LED then converts this MVS into a modulated infrared signal. It's converted into a modulated infrared signal. Okay, now the modulated infrared signal then travels to the air, okay, until it reaches this receiver. All right, until it reaches this receiver diode. The receiver diode then converts it into a binary signal, which is then sent to the Arduino. Okay, so now this modulated infrared signal is sent to the air and is received by the receiver diode. Okay, receiver diode. The receiver diode convert the modulated infrared signal MIS into a binary signal, which is then sent to the Arduino. Okay, which is then sent to the Arduino. Now there are several protocols. The decoding of the binary signal depends on the protocol. So the Arduino then decode the binary signal. Okay, but the decoding of this of this binary signal depends on the protocols. Now we have several protocols. Okay, that the remote uses. Okay, but the remote that we are using for this project, like this Arduino kit remote or any project kit remote, mostly use what they call the NEC protocols, the NEC protocols, NEC protocols, and that is what we are going to be using. So now that's what we are going to be looking at today. Now other remotes have their own different protocols. For example, let's say you're using a TV remote. The protocol of TV remote, let's say a Samsung TV remote, or an LG TV remote, or any they have their different protocols. Okay, but this NEC protocol is like a generic protocols. It works with most of the remotes that are not, should I say, branded. Okay, all right, so that's what we are going to be looking at today. Now let's look at our connection properly, on how to connect our project together. All right, so the first thing we need to do is to connect our receiver diode, our infrared receiver diode into the breadboard. Now this is, there are different kind of you might come across different kind of receiver diode. Now this one has a metal covering, right? So this part is called the signal. The first leg is called the signal. So that you can see, the first leg is called the signal, while the middle leg is called the ground. All right, that is the ground. That is where that is the ground, and the right leg, okay, or the right pin is called the VCC. Okay, it's called the VCC, and that stands for voltage common collector. Okay, VCC stand for voltage common collector. So basically we have something like this. We have something like this. Let's say this is our diode. I hope you can see it is a diode. Now this leg is called the signal. This is signal. The middle is the ground, G and D, and this other pin goes to the called the VCC, voltage common collector, VCC. Okay, so we have our connection this way. Let's put our diode receiver, okay, in our breadboard. All right, so the first leg, which is the signal, okay, goes to the, that is the signal, which, like I said, the signal of the Arduino, which is the end of the pins here from pin 1 to 13. So that is where your signal goes to. So let's use our green jumper cables. Green jumper cable. We connect. Let's leave a space here. So we connect from this part to any of the pins here. So let's use pin 2. Okay, and we connect the middle leg, which is the ground, to the ground of the Arduino. Connect to the ground of the Arduino. Then the last leg, which is the VCC, is connected to the voltage of the Arduino. Let's say 5 volts. Okay, it's connected to the 5 volts of the Arduino. So we have a connection like this. Okay, so this is a basic is a basic connection. Is a basic setup. Now the next thing to do is we have to the next thing is to check if our setup is correct. All right, so we have to connect our Arduino to our computer and open the Arduino IDE. And when once you open the IDE, you put our code into the IDE. IDE rather. You put our code into the IDE, and once you press the button on the remote, you should be able to see the signal. We should be able to receive the binary code, the code. Okay, now it's hexadecimal code. We call it hex code. The hex code of the particular button which you have pressed on. You have to be able to see that in the in our IDE. Okay, so let's see that. Let's do that now. Let's connect our Arduino to the system, to computer, and then open the Arduino IDE. Okay, so as you can see now, it's connected. Now we're going to open our Arduino IDE. All right, so this is our Arduino IDE, and for the sake of time, I have put the code here. I'm going to briefly explain what this code is all about, what's all about. Okay, now the first thing to do here is to include the IR remote library. Okay, that's the first thing to do. You have to include the library. Okay, and by doing that, you use hash include IR remote.hpp. Okay, now this is the new updated library. Okay, the old one is usually irremote.hp, and if you use that, you might not get you might not be able to, you might not get a good response from that. Just literally. All right, so for the updated library, use ir.hpp. Right, so now to define our variables, constant integer receive pin, pin is pin 2. Okay, we use pin 2, that is receive pin. Okay, And then our setup, the first thing to do, because you want to monitor, you want to see the code, you want to see the hexadecimal code that each of the buttons of your of the remote, each of the buttons of the remote will produce different hexadecimal code. All right. So to do that, you have to set up your serial monitor by using serial.begin and 115200. You can use 9600 if that is what works for you. Okay. Then set up our IR receiver.begin. You want to receive pin, enable LED feedback. Okay. Don't forget to put a semicolon. Then serial.print lane. Okay. IR receiver, it's going to print the IR receiver. Ready. Okay, press buttons on your remote. So that's what's going to print out the moment you upload the code. We'll see that in a jiffy. Then what do you want this to do? That is a loop. Okay, so if the receiver decode, like if the receiver is able to decode, okay, it's going to print the protocol. Okay, serial.print protocol. It's also going to print get protocol string, you know, the IR receiver decoded IR data. Okay, it's also going to print a lot of things. Also, it's going to print code OX. But the main thing we need here is the hexadecimal code. Okay, so the hexadecimal code is what we need, and that is the main thing we need. However, once we upload this code, we are going to see every other the things that are here, right? That it's that are here. But then what we need is hexadecimal code, right? So we can just take whatever we need. All right. So now this is the code. Let's upload this code and see what happens. Finger crossed. Okay, done. Now done uploading. So let's open our serial monitor. We're going to this point. Open our serial monitor. Okay. And let's press. Let's see. Let's press our remote control and see anywhere if you're gonna get any response from there. Okay, as you can see, I just pressed this, the red, and this is the response. This is what it brought out. Okay, now you have to be careful while pressing. If you press it more than once, or if you press it for a long period of time, if you hold it for a longer time, it's like basically it's going to repeat the informations. Okay, so now you can see what is bringing out the NEC protocol. The code, this is the hexadecimal code, the 0xA758FF00. Now that's the hexadecimal code for this button that I pressed. Okay, and that is the only thing we need. That's the only information we need, basically, from all these data here, and that is what we're going to use whenever you want to incorporate other things into this particular project. Let's say, for example, you want to use this remote control to turn on your RGB light. Okay, so you're going to make use of only this hexadecimal code from this particular button. All right, so let's look at another button. Okay, so let's look at this green. Let's press this green. Okay, and the green is bringing out, you can see OXA659FF00. Sorry, 0xA659FF00. So this is a hexadecimal code of green is different from the one of red. So now the thing is this: since we don't need all these other data, other value here, we only need the hexadecimal code. We can just remove every other thing from the loop. Okay, so let's just remove every other thing from the loop and leave the hexadecimal code and probably you can leave this as well. So let's remove this. Let's take this off. We don't need this. And for now, we don't need that, and also we don't need this. We don't need the protocol. We don't need that. And what else we don't need? Okay, so let's reload it again and see what's going to come out. Let's just leave this 3. So let's re-upload and see what will happen. Okay, and let's press a button. This time let's press a power button. Okay, we're going to press a power button and see what happens. I'm going to press it now. Okay, let's see. Okay, now it's bringing out okay, now this hexadecimal code and 40, okay, and then this dash. So I believe the first one here, the raw data, is the hexadecimal code, and this other one here is the 40. All right, and then the serial print, this dash is that's what is here below here, you know. So I don't think we need this. I don't think we need this. We only need this decoded raw data. Okay, so if that's what you need, just remove every other thing and leave what we need. Okay, but just have in mind that we only need the hexadecimal code, and don't press it for a long time so it will not repeat the data. So let's press another button. I want to press the white button and see what happens. You can see the white button, BB44FF00, and it's different from this one here, BF40FF00. Okay, so now that shows that our setup is correct, and we are able to send signal to our infrared receiver diode. Now in our next project, what we're going to do is we're going to incorporate other things into this setup. We're going to use the infrared to control RGB LED light. Your red light, green light, and blue light, and probably other, secondary colors from the RGB light. Okay, so ladies and gentlemen, that's where we're going to stop from now. And I will also advise you, probably you should also try and play around with this project. Try and use other remotes. Okay, try and use other, maybe your TV remotes. If you use your TV remote, I believe you're able to see the protocol of, from the TV remote. I think I might try it now. Let me try and get my TV remote and and see what will happen if I'm able to get the protocols, from my TV remotes, and see, compare it if it's the same as the protocol of this particular remote I'm using for this project. All right. Okay guys, so I just brought my TV remote. Here is my TV remote, and we are going to test it and see if it's going to if the receiver will be able to receive signal from this TV remote. Okay, but then we have to include those things that those code that we removed earlier, so that we're able to see the protocol of the remote. Okay, so basically what I'm going to do is I'm going to put back the code here. Okay, so I'm going to put back all the code so that we're able to see the protocols, or the protocol of the remote. Okay, so now I've done that. I'm going to re-upload, and that's uploading done. All right, so now I'm going to press the remote. I'm going to press any button from the remote. let's say I'm going to press the 1. Okay, and let's see what information we're able to gather from there. Okay, we can gather from here that the protocol is also NEC. It's also making use of NEC protocol. Okay, as you can see, it's also making use of NEC protocol, but the code is different: 0xFE01BF00, and the command is 0x1. The protocol also is same protocol, NEC. Okay, so if you able to do the project, just try different remote and try and see the protocol of the remote, maybe the one you have in your house. Okay, so thank you for tuning in today. That will be the end of today's video. In our next video, we're going to, like I said earlier, we're going to incorporate RGB lights into our infrared project, and see how we're able to control RGB light with our infrared remote. Thank you once again. See you some other time.